clinic. And our guest speaker is David.
Hi, everyone. So, just conflicts of interest there. I am the owner of Beacon Ortho in St. John, New Brunswick, and the data we're presenting today is based on our clinic numbers for the last 2 years. We have no other funding or sponsorship or material support for any of the technology used or 3D printing, CAD software, anything like that, and no other conflicts of interest to declare. On the next slide, I'd like to really acknowledge my staff who's all here today, students and the researchers that we work with for all their hard work in exploring this stuff with me. We started the business around the idea of 3D printing a lot of stuff. As well, we've got a research relationship with the UNB Marina, the Manufacturing Center of Excellence. And finally, I'd like to thank my dad for giving me a 30-year education on computer-aided manufacturing and CAD design. And some of the software that we use, I've learned since I was this big. So seeing it come into our industry has been really interesting. Most importantly, 2 years ago, there was like 2 talks on 3D printing. It's so encouraging to see 30-plus authors here doing research, doing design and iteration to explore this stuff. And I really appreciate Matthew, who just went. He gave a perfect preamble because a lot of the stuff he's talked about is included in our talk. Just a quick introduction to the idea. Check sockets, they exist to be tested, modified, changed. Every time we iterate traditionally, we go through a full fabrication cycle. We're either recasting or refilling using a jig, using time, labor-intensive processes. And it's a combination of both my technician and my time. I just saw a couple other estimates from other clinics, and we're on track with about 5 to 7 hours of combined clinical and technical labor to make it happen. And a small clinic like ours, we've been here 3 years, and we have 1 prosthetist, 1 orthotist. They're hit the hardest. When you have to remake a socket, it can be quite costly. And so I was really interested in 3D printing anyway, but I got very curious about what this would cost and what it actually costed to do this. And can FDM printing make a completely different design from the same basis as cost effective as adding a pad? And see if we can refit someone and get the clinical work done in the most cost-effective manner possible. Part of the reason for that is reimbursement's a big part of that. I've cited the Ontario ADP manual, which states you can have 1 check socket per device. Practically speaking, I know that's not always how it's done. But in New Brunswick, we charge for parts and labor. That's what's requested from our payers. And we have a nominal fee of $1,050 for materials, and our labor separate. And I've rounded that to $1,000 for purposes of this. A couple caveats. The actual numbers used, the data and the socket counts are from our clinic using chart review. But to protect privacy and stuff, we've used salaries that are from research papers. And the other big one is we started the business around this. Jordan and myself have both made large personal investments in 3D printing and stuff like that. I didn't want to convolute the conversation. So the exercise we're going through, we're going to do a little bit of math together and explain if you want to start today from 0, where's your return on investment? So I hope at the end of the talk we'll get to that. Okay? So how we do this at Beacon, just to give you some context, we have 4 staff, myself, Jill, an orthotist. We've got a registered tech, and we have an engineer in training on staff who's just about to finish her master's in the empirical research on the sockets we're using. And how we go through the process, we cast in either fiber casting or plaster wrap. We fill that with plaster, rectify the cast, thermoform, trim and finish, and then we have our fitting. At the fitting, we'll do the same iteration that every clinician does. We'll add pads, we'll heat modify, try and reduce. And we've estimated 1 to 2 hours of clinical time to get to our first check socket, and then 4 to 5 hours of tech time getting the molds ready and molding and stuff like that. All stuff you're very familiar with, and lots of folks are talking about it here. How we apply 3D printing. So we start with a scan. We use an Einscan H2 structured light scanner, which is, you can certainly do it with an iPhone. You can do it with Creality. You can do it with $1,000, $5,000. This is about a $10,000 scanner out the door. And we purchase it really because capturing motion artifact when people are moving across joints, or especially with baby helmets, we want to track the object. And if it's moving, some scanners really struggle with that. So we actually do use tracking markers. Someone asked that in the last presentation for certain things. We use a scanner. We design the socket. We use Autodesk Fusion for the large majority of what we do, but we use Nomad Sculpt. Jordan uses a different CAD-driven software for tool making and other things. And we just have a variety of softwares that are put to purpose. We've recently purchased what Matthew just mentioned, a Bamboo Lab H2D, and we've been around the block with printers, and we started with Creality machines, the same ones Dr. Mayo is using in Ukraine, and upgraded to Prusa machines, and found that the Bamboo products are, you put it on the shelf, you press play, does the job, all the benefits that Matthew highlighted, and they're a workhorse. And we have been exposed to 12 or 15 different Bamboo machines with over 12,000 hours of printing time, and the maintenance cost has been nominal. So they're really cost-effective way to get into this process and use them. They don't have a huge height. 32 centimeters is your maximum height. So there's some limitations there with geometry, but it's an excellent starting point. And then fit, we spend about 10 to 20 minutes finishing the print, getting it ready for our fitting, and then we'll do our fitting as traditional. We've chosen PCTG, which goes back to one of the very first 3D printed sockets I did at Sunnybrook 10 years ago through a third party. And it's the same base resin that's carried on through. Now it's available publicly through a company called 3D Fuels in the Western United States. Something important to recognize is print time is machine time. It's not human labor. So the cost of that is much, much less. And the printer works often overnight. Some of our designs require human intervention during the print. But all the advantages of having video on your phone, you can stop the print, start the print, and troubleshoot as you go. And then the digital file is a record, and this is one of the biggest advantages of this process. The file itself is there forever. And if I need to make a design change, I can go back and make the change. And we have that file. We can repeat prints. We can change it into a water leg or anything else you'd like to do, or add creative things like what Matthew demonstrated with Meshi. Beyond prototyping, so just a short list of things that we've done. Definitive molds, lots of coverage. You guys saw me present that a couple years ago. We've made injection molds. We've made a handful of dog things. Jigs and tooling. If you need jigs and fixtures, we've made our VFJs with 3D printing and Princess Auto parts very cost effectively. Patterns, templates, knee braces, cranial helmets, and we've done the transhumeral fitting, transfemoral fitting, partial fingers, and we have one client who has a prosthetic thumbnail. Very interesting case if you're interested. So how did we do this analysis? I went back through, we started doing this in earnest with patients in January 2025, looked at the last about 18 months of how we've operated with 3D printing, looked at 10 FDM prints and 10 traditional sockets from the last 2 years, and we looked at how often we iterated, how many new sockets we made, how much the filament weight and the printing time came into this. And then we just went through our charts and saw time between fittings and how often we saw people to get an idea and estimate the numbers for this. As I stated before, we've used $65 for clinical rate and $25 an hour for technical rate from research in 2022, rather than give Jordan my salary to you guys. And then we looked at our purchase records, looked at the materials we bought, the printers, and itemized that per iteration to see how much an individual unit would cost. As I stated, we've had an incremental investment over the last 5 years, and we've taken the stuff that Beacon has done to get this off the ground with our current state and amortize that over a 5-year life cycle to purchase a new printer or a new machine, as that timeline will get shorter because the technology is moving so fast. And then finally, our actual independent variable, the thing we're looking at, or dependent variable rather, is how much it costs to do one iteration. What's the marginal cost to, let's do it again. Why not? Let's do it again. I'm sure the clinical side is interested in how we deliver the care. So at our assessment, we talk about the options of how we would approach fitting. And often I have a practice with new amputees of doing a plaster model and modeling it in plaster and thermal molding, so they have an idea of what current state reality is across the industry. So if they go to another clinic, they might not get a 3D printed socket, so managing those expectations. And also weight is a factor. We're not doing this with 500-pound folks. And also, preference, personal preference. So ultimately, it's the patient's decision. They do sign informed consent, acknowledging the risk, which we just find is similar to a thermoplastic socket at this point. We do the fitting. often dispensed to home, and then we have regular monitoring as typical, but often we're planning on reprinting something in between sessions and often saving appointment time doing that. So with FDM, one of the biggest observations we had is, and I can't excuse my personal bias towards 3D printing, but I was much more likely in the cases of 3D printed trial sockets to say, oh, let's just reprint it, because I felt it was so costly before I knew the numbers. And what that resulted in, we had, on average, 1.7 traditionally made sockets per definitive cycle, where we had two to three sockets per definitive cycle for a 3D printed socket. So that's how many sockets we fabricated. Pads, stuff that we would do with any method, we've kind of left that out. This is, are we making a new object? So the numbers that I'm sure you're interested in. So, and we have a bill of materials, how we estimated this at the end if you're interested. But we found that on average, it's costing us about $500, $446, to make a thermalin socket glued to a block with Scotch cast. And I should point out that we chatted about this at ISPO, and some of our European counterparts said, you send plastic home, period, full stop? Where they're laminating all the time. And so the method that most of us who went to George Brown and BCIT have been taught is standard practice, is not used elsewhere in the world because of safety concerns, because of the same concerns we're raising about 3D printing. When we use an FDM part, the material cost is generally around $50 to $55. Labor is much, much less because it's kind of incidental. The machine runs and then we polish off a couple burrs here and it's ready for fitting. Install some hardware. So we came to about $85 per socket in terms of the actual unit cost to redeliver a new iteration. And in both cases, we had clients that needed a bunch of sockets. And in both cases, these were early fits, post-trauma, very active folks, around 200 pounds. And we found that in case number one, we went through 4 sockets to get to our definitive fit over the course of 4.5 months. And then in the FDM iteration, that client's actually on socket number 6, I think, because I can't keep up with how much he's shrinking. The labor time for that, if we're making 4 sockets, is about 24 hours of human labor. So it's a lot of clinical time, technical time eaten up. And it's about 2.5 hours on the 3D printed side. The iteration changes are taking me about 15 to 20 minutes. And my initial design is usually, to get to a check socket is usually half an hour. So back to our first part of the conversation, funding schedules usually assume 1 check socket. You can bill for 1 check socket per print. We bill it now as diagnostic fitting for the same price, so regardless of the semantics of what we're using. And so we can iterate at a very cost-effective method to get the clinical work done, get the fit right. And more anecdotally, we have folks that are now 18 months, 2 years into the definitive fit, and I think they have less need for follow-up. So I can do a much better job up front and try and get it, like there's no perfect socket in my short career. I've never made a perfect socket, but we have less need for them to come back. I think we're getting to the end here. The investment we made in reality is a little bit more, but you can see the numbers here, and this is to buy a printer, buy a scanner, invest in the software. The learning curve is steep no matter what software you choose. And I've heard common software and common ideas about the advantages of all this stuff, the disadvantages, and it's a new tool in our toolkit. And I think it's imperative that both technicians and clinicians get on the learning curve and learn enough to be creative. And the conversations we're having with folks who are doing this more regularly, there's a lot of commonality and a lot of, oh, I see how you did that. Oh, I can do it this way. And that feedback loop that's starting to spin is, I'm really excited for it. I can't wait to see where we'll be in 10 years with this stuff. So you see the recurring costs, savings, stuff like that. And the actual salient thing here is the return on investment. So we're a very small clinic. We did about 20 jobs in 2025. We're going to be about maybe 40 full prosthetic jobs in 2026. And if I do 24 sockets in a year, it pays for itself with all that investment. And yes, there's a learning curve. This is an exercise in what the math is on if you want to start this tomorrow. A couple observations. Most of our sockets, I like to think I'm okay at fitting now, but most of our sockets were acceptable on the first fit. made design changes, iteration changes, and retaining a thermoplastic article. So some 3D printing technology, you have a very difficult time of hand modifying it post, especially with heat. But using a thermoplastic, using most FDM materials, you can change it with a heat gun. You can glue to it, you can add pads, and a lot of others are reporting on that stuff. So it's dovetails into our current workflow very, very well. But the biggest difference was when I put a pad in, popliteal pad or paratibial pad or something like that, we're making a specific change. And we can backline with leather and do things like that, but it's very challenging to truly reduce a socket in between fittings without making something new. Most of our reprints have been a global volume change. So I've changed it 1 or 2% due to the socks I see, and trying to judge how much closer I can get to perfect. In a couple instances, we went a little far and we could back up because we had the previous design. We've done that in a couple cases. And something creative that we've done, we're currently using the OSER titanium adapter for a lot of folks. And when we're doing that, we have the whole design file, including our base alignment. So we save a jig transfer appointment. We print a thin-walled mold, fill it with plaster, and Jordan laminates over it. So it dovetails into our definitive fabrication as well, which has been very useful. One of the biggest findings is kind of small there, but the utility of these machines, as I'm sure you can see from everyone's talks, it's only limited to what you guys can do. And I think a lot of folks have technicians who are diving into the deep end on the CAD design, stuff like that, but I'd really encourage every clinician that can get their feet wet with it. Sorry, 1 minute. Yeah, of course. Sorry, this is our socket. It is not perfect, but it's currently what we're doing these days. So fluency in the technology is really what's driven the innovation in our clinic, and every one of our staff can have a pretty deep conversation about CAD now. And so the things we can do, even when I'm doing the CAD design for an orthotics project or trying to do something that we've never tried before, we're doing a dog wheelchair right now, which has involved creativity from our whole team. Having an understanding of the technology, now we can take that to the next level and do all the amazing things that our colleagues are demonstrating and what we're doing. I've focused a lot on the meat and potatoes because diabetic transtibials are my bread and butter work. And I don't often have call for a very complicated cosmetic cover. They want foam and socks, but the VarioSure that Matthew mentioned is exceptional for doing that. And one of the biggest advantages of that is it's just a removable part. It's not a piece of foam you have to cut off. And the waste with regard to check sockets is the biggest reason we kind of went this direction. And now with minimal waste and minimal investment, I think I can do my job better with 3D printing than I can by hand. This is not a really rigorous research study, so there's a few limitations. It's just 10 of each method in a very small clinic. We're not using real labor rates. And the definitive outcome capture not complete. That's just because we have a couple in-process projects that are still going on. The traditional per case costs, I've heard some other estimates of time here at the conference, and I think we're maybe a little bit overstated, but not much. And as I stated before, the socket counts how often we're reprinting. It doesn't count putting pads in, just doing the regular job we would always do with any socket. And so that's something we'd like to tease out. One of the biggest takeaways from this is hand modification, being a clinician, using your judgment. All those skills are going to remain. The ability to make a right socket into a left socket, which I've seen another clinician do, it remains useful. And even at a low volume, payback, like if you're not doing more volume, payback can stretch out over longer. And the bigger the investment you make, if you buy a $40,000 printer, that's obviously going to stretch out for you. So, a couple take-homes. The marginal cost to redo something is 5 times cheaper with a 3D printer based on our estimates. Because of that, we're more willing to redo a shape, try something new, try a different approach. And in several cases, I've tried this socket, and I've made a fundamentally different design choice and made that socket. And they've been able to pick which one they find more comfortable. So our estimated payback based on our current volume is about 4 years. But I expect in the next year or two, our volume is going to increase, and there's a benefit to it. The more you do this, the cheaper it becomes, obviously. Yeah. And then a couple sources, and That's how you can find us online. I am not responsible for our Instagram, but it's pretty good if you want to see what we're up to. And you can email me. It's just david.smith@beaconortho.ca. And I'm happy to answer any questions. Thanks for your time, guys.
Questions? Anyone? Going once? Thank you very much.
Thank you.
Just a note, the technician, orthotics technician competition will be starting in about 5 minutes. So grab your lunch